what a hierarchy is. Like, a hierarchy ranks things from very least specific to more and more specific as you go down. Like, a bird is a type of an animal. A robin is a type of a bird. A pigeon is a type of a bird. A dog is a type of an animal. So we had seen this before in geometry class. But now let's kind of play a little game called always, sometimes, or never. Always, sometimes, or never. Like, tell me about a dog relation to an animal. Will a dog always be an animal? Will it sometimes be an animal? Or will a dog never be an animal? Well, a dog is always an animal. And how can I tell that? Because dog is below animal in the hierarchy. Like, when you're below what you're questioning it to be, you know, we're questioning it to be an animal, you will always be that. But how does a pigeon relate, how does a bird relate to a pigeon? Will a bird always be a pigeon? Will a bird sometimes be a pigeon? Or will a bird never be a pigeon? Well, since bird was above pigeon, right? I mean, a bird can sometimes be a pigeon, but it's totally possible for a bird to be something else. A bird could be a robin, right? So, since bird was above pigeon in the hierarchy, that answer was sometimes. So, let's see how that game works with this quadrilateral hierarchy. Okay, first let's study it. This is the most least specific quadrilateral that we have around. It's just called the quadrilateral. It's just a polygon with 4 sides. And then if we branch off to the right of that, the next least specific is a trapezoid. It's just got at least 1 pair of parallel sides. And then hopefully you understand that an isosceles trapezoid is a type of a trapezoid. It's still got at least 1 pair of parallel sides, but it's also got base angles equal. But notice this, a parallelogram is a type of a trapezoid because it does have at least 1 pair of parallel sides. It's actually got 2 pairs of parallel sides. And then this rectangle right here, according to what the hierarchy says, this rectangle is a parallelogram. It does have 2 pairs of parallel sides. We just don't mark them the same, but it's true that these guys are parallel to each other and those guys are parallel to each other. This isosceles trapezoid, or a rectangle, is also an isosceles trapezoid because it's got at least 1 pair of parallel sides and it's got some base angles equal, right? So that's all cool in the neighborhood. What's also a fact is that a rhombus is a type of parallelogram. So these sides it's got 2 pairs of parallel sides, but what's fancier about it, it's also got 4 equal sides. And then hopefully you kind of saw the little marriage that if a rhombus and a rectangle got married, you know, something with 4 equal sides and something with 4 right angles, they would have a square. There's just like one oddball in this family tree besides the quadrilateral, if you don't count that guy. Right? The only oddball is a kite, because it's the only one that's not connected to trapezoid at all. Like right here, there's its own little hierarchy of trapezoids. Like all of those are connected underneath the trapezoid in some way or another, meaning they all have at least 1 pair of parallel sides. This kite is not, meaning it's the only dude besides the plain old quadrilateral that does not have at least 1 pair of parallel sides. It's just got 2 distinct pair of consecutive sides equal. So, oddball. That's alright though. Let's play that always, sometimes, or never game. So we need the hierarchy. This is like our answer key to this game. First off, we're just going to fill in the blank with always, sometimes, or never. We're going to do A, S, or N. And parallelogram, will it always be a polygon? Will it sometimes be a polygon? Or will it never be a polygon? Well, this one's like so generic, excuse me, that it's easy. A parallelogram will always be a polygon. Right? Remember the rules to be a polygon from way back in the day. So now let's really get going with this. A parallelogram, I'm going to say this first word, but instead of saying that word right there, the second word, I'm going to say its definition instead. Will a parallelogram, right here, will it always have 4 right angles? Will it sometimes have 4 right angles? Or will it never have 4 right angles? Well, if we compare the 2 shapes in the hierarchy, isn't parallelogram above rectangle in the hierarchy? If you're above that guy, you will sometimes be what that is. A parallelogram will sometimes be a rectangle. A parallelogram will sometimes be a rectangle. Sometimes a parallelogram will have 4 right angles. It'll look like this. Isn't this a parallelogram? And this certain parallelogram right here does have 4 right angles. So let's move on. A rectangle. Will a rectangle always have 4 right angles and 4 equal sides? Will it sometimes have 4 right angles and 4 equal sides? Or will a rectangle never have 4 right angles and 4 equal sides? Well, a rectangle is above square in the hierarchy, so a rectangle will sometimes be a square. Just like if I go back here, one more, please. A bird will sometimes be a pigeon, right? Since bird was above pigeon in the hierarchy. If you're above the guy in the hierarchy, that answers sometimes. A bird will sometimes be a pigeon, but it doesn't have to be. A bird could be something else. Just like a, where were we? A rectangle will sometimes be a square. Like, look at that guy. Does that have 4 right angles in it? Yes, so it's a rectangle. But it's also got some more stuff going on. It's got 4 equal sides, so it's called a square, but it really is a rectangle because it's got 4 right angles. So let's do quadrilateral. A quadrilateral will always be a rhombus, sometimes be a rhombus, or never be a rhombus. Well, quadrilateral is above rhombus, so that answer is sometimes. A trapezoid will always be a square, sometimes be a square, or never be a square. A trapezoid is above square in the hierarchy, so that answer is sometimes. Let's see if I'd like you to write that down on your hierarchy sheet right here. That above means sometimes. Above means sometimes. Let's continue on. A square, will that always be a rectangle, sometimes be a rectangle, or never be a rectangle? Well, will a square always have 4 right angles, sometimes have 4 right angles, or never have 4 right angles? Well, here's a square, and it's below a rectangle. A square will always have 4 right angles in it. So that's an always. Square was below rectangle in the hierarchy, so that answer was always. And I'll go back 3 slides again here real quick. Will a Labrador always be a dog, sometimes be a dog, or never be a dog? A Labrador will always be a dog, right? Because if you're below something in the hierarchy, you will always be what's above you. Like a Labrador will always be an animal also. So our other rule that we could write down here is if above means sometimes, then below means always. Below means always. So let's do this one. A rectangle will always, sometimes, or never be a parallelogram. Well, since rectangle's below parallelogram, a rectangle will always have 2 pairs of parallel sides. A parallelogram will always, sometimes, or never be a square. Well, parallelogram's above square, so that answer is sometimes. A parallelogram will sometimes be a square. A quadrilateral, always, sometimes, or never be a rectangle. Quadrilateral is up here, and rectangle down there, so quadrilateral is above. And a quadrilateral will sometimes be a rectangle. Hopefully that one makes sense to you. But it could be other things. It could be a trapezoid, it could be a kite, it could be a parallel, whatever. You know, but a quadrilateral, sometimes it will be a rectangle if it just so happens to have 4 right angles. A square will always, sometimes, or never be a parallelogram. A square will always be a parallelogram since it's below. Square is as low as you go, my friend. It's the lowest thing. A square is all of these things up here put together, right? A square is just like the collage. A square is a quadrilateral. A square is a kite. A square is a rhombus. A square is a rectangle, etc. A square is all of those. So I would like you to try these on your own. Just pause the video real quick and just answer always, sometimes, or never. Trapezoid is above rhombus. Above means sometimes. A rhombus is below a parallelogram. A rhombus will always be a parallelogram. A parallelogram will always, sometimes, or never be a quadrilateral. Parallelogram is below, so that's always. I hope that one makes sense to you. A parallelogram will always be a quadrilateral. A rhombus will sometimes be a square, and a trapezoid will always, sometimes, or never be a rectangle. A trapezoid will sometimes be a rectangle since it was above. A few more. Go ahead, pause the video, and try those. There's the answers to those, but let's talk about 19. A rectangle will always, sometimes, or never be a rhombus. Well, here's a rectangle, here's a rhombus. It's like they're side by side, so it's not like it's above and it's not like it's below, but a rectangle will is sometimes a rhombus because it happens right here. Isn't this a rectangle? Doesn't that have 4 right angles? Isn't that a rhombus also? It's got 4 equal sides. So that answer was sometimes. Even if they're side by side, that answer is sometimes. So when do you answer never? Right? We didn't answer never at all. If we're playing the game always, sometimes, or never, it'd be nice to know when you answer never. Well, how about when you do this? An equilateral triangle, if I could spell things correctly, an equilateral triangle is always, sometimes, or never a pentagon. Well, that answer is a never, because I'm comparing shapes. This is a triangle, this is a pentagon. They're not even the same shape. A rhombus will never be an octagon, because this has 4 sides, this has 8 sides. Back here we answered always or sometimes because we were comparing quadrilaterals to quadrilaterals. We were comparing the same kind of polygon to each other. You'll answer never if you've got one type of polygon compared to another type of polygon. So always, sometimes, and never is such a simple game to play when the hierarchy is in front of you. But the hierarchy won't be in front of you for most of the test. And there'll actually be like a homework quiz question that'll say, please draw the quadrilateral hierarchy. So what we need to do is learn to draw the quadrilateral hierarchy for ourselves. So get out a separate sheet of paper. And if I move a little too fast for you, you can always pause the video. But on this separate sheet of paper, the first thing you got to do is tell me where the top of your piece of paper is, because you can have this portrait or landscape or whatever. So wherever your piece of paper is, tell me where the top is, and then here's what I need you to do. Just watch me draw, and then when I say draw, you draw this same thing. But to draw the hierarchy, the first thing we want to know is how they're all connected together. So what we do is we draw this. So just watch this. Make this the same size as I'm making in relation to my piece of paper. I want to draw 1, 2, 3, 4 guy deal with the old straight edge. So you can pause the video and draw that. And then we want to do this. Take the straight edge and connect from here to here. Boom. Go ahead and do that. And the final move is to connect from there to there. And this is what I call the pair of pants. So this is how they're all connected together. Why do I call it a pair of pants? Because it's kind of like you've got some guy right here. Here's his sleeve, his neck hole, his other sleeve, and then doot. There's his hands, and his neck, and his head, and then there's his feet right there. So I kind of call this the old pair of pants. So now that you see how big to put this on your piece of paper, I'm going to go to the next slide here, which is just my pair of pants a little bit bigger. And everywhere there is a place of intersection, that's where a quadrilateral goes in this hierarchy. So don't put these dots, but you can see 1, 2, 3, 4, 5, 6, 7, 8, because there's 8 different quadrilaterals. And remember, this is going to be a test question for you to actually draw this on your own. So here's what we'll do. We'll take shape 12 of our geometer, and we're just going to draw the most generic hierarchy you've ever seen right here. So take shape 12, and at all 8 of those spots, we're going to put shape 12. So there we go, 8 different times. And this is nice and generic, because what we're going to do is we're going to name each shape, and then we're going to mark it by its definition. So there's our 8 quadrilaterals. And then the way I fill this out is it's pretty simple. I just have a little process. It's like I go from easy ones that I know to more difficult ones. So obviously, being as how this is the hierarchy of quadrilaterals, a quadrilateral is at the top. You must spell it correctly with no abbreviations. So it's quadrilateral. And then remember, its definition is it's just a 4-sided polygon. So we'll put the definition with an asterisk by it. It's a 4-sided polygon. Maybe if my pen would work. And then we'll mark it according to its definition, and that's all that it needs for markings is 4 sides, and it's got to be a polygon. So that's the quadrilateral. Duh, it's at the top. It's the hierarchy of quadrilaterals. Remember, we're going from least specific to more specific. Well, we should know the dude at the bottom by now. He's the most specific of them all. He's the square. So his definition is he's got 4 right angles, and we can abbreviate in the definitions, just not the name of the shape. 4 right angles and 4 equal sides. So again, the name of the shape must not be abbreviated, but in the definition you can do whatever you need. And to mark that, we put the 4 right angles and the 4 equal sides. Tick, 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 tick. So that's the first 2 that I'd go to. Quadrilaterals at the top, squares at the bottom. Then we've got the old oddball in the family. He's way out in left field. And if you know anything about how like a baseball diamond is arranged, this is left field over here. So our kite, he's the weird guy in the family because he doesn't have any parallel sides. So he's way out here in left field. And his definition is the hardest also. It's got 2 distinct pair of consecutive sides equal. 2 distinct pair of consecutive sides equal, and then that means like these 2 guys are the same and those 2 guys are the same right there. Then from there I kind of move over to this brother right here because he's like this whole hierarchy of trapezoids going on right here, so he's the trapezoid. Gotta spell him correctly. Trapezoid, that's why I say trapezoid instead of trapezoid. His definition, he's got at least 1 pair of parallel sides. At least 1 pair of parallel sides, and then we mark him like so. There's at least 1 pair of parallel sides. Well, directly to the right of that is another type of trapezoid. He's the isosceles trapezoid. Remember, you can't abbreviate the name of the shape here, so it's isosceles trapezoid. Got to be spelled correctly also. He's the hardest one to spell. His definition is so easy. It's the same definition for trapezoid all over again. It's got at least 1 pair of parallel sides, but it's also got base angles equal. So, and base angles equal. So to mark them, I'd be like boom, boom. And then to mark those base angles, the arc marks have to be on the same parallel side, the same base. So it's like, see how both arc marks touch that guy right there? So there's my isosceles trapezoid. And people are pretty familiar with the guy in the middle. The guy in the middle is the parallelogram. Para, double the L, O, gram. Parallelogram. His definition is he's got 2 pairs of parallel sides. And we've got, there's 1 pair, and then the second pair's got to have a different amount of arrows on them. So it's down to the last 2, between a rectangle and a rhombus. And we used to mess these up more often than not. These would be the 2 that would get switched around until we started thinking about, well, what's the definition of a rectangle? Well, a rectangle has 4 right angles. You know, it wouldn't have 4 left angles. It would have 4 right angles. So this is the guy on the right. He's got 4 right angles, and that's my rectangle definition. 4 right angles. And then finally our rhombus over here with an H, rhombus. I always say that's what our friend Rom takes to school, the rhombus. It's got 4 equal sides. So, So learning to draw it on your own is a great deal. Remember, this will be a test question, and even further than that, it will be draw the quadrilateral hierarchy, mark each picture according to its definition, put the name of the shape next to it spelled correctly with no abbreviations, write the definition next to each shape with an asterisk, list all properties with a hyphen underneath it. So we haven't learned the properties yet. That's what we'll do later, but there's more to this. So I hope you start taking it very seriously of getting these things memorized. What we did in class is we took our piece of paper and we flipped it over and we tried to draw this again ourselves. I asked you to do that, but I can't control what you do.
Now that we've learned how to draw the quadrilateral hierarchy, we can use it to do some basic stuff for today, which is find the area of some basic quadrilaterals. So on your yellow card here, you'll see that you only have 3 different formulas, one for a trapezoid, a parallelogram, and a kite. So we'll kind of see how the hierarchy helps us. First, we'll recognize what type of quadrilateral we have here. And you see we have just one pair of parallel sides, so that would be a trapezoid. Okay. His definition is it's got at least one pair of parallel sides. If we go to the yellow card right here, we can see our formula. So we'll write it down first. So I like to do that so we learn how to memorize them a little bit better for the ACT. So, sorry about that, guys. So the height of this guy is the perpendicular distance between the bases right here. So we've got our 2 green orange bases right here. One of them's base 1, the other one's base 2. It doesn't really matter which one's which. So we'll sub in. I'll do my area is going to equal 1/2 times my height of 7 times base 1 plus base 2. And I like to just write it down like that so that way I can see that we put all the numbers in the right place. And then I can add my 15 and my 23 together because that's in parentheses. And when I do that, I get myself 38. So I'll just like lightly scratch that out and put 38. And then I just do 1/2 times 7 times 38. Or another way to do that is save that 1/2 for last, do 7 times 38 and hit equals. And instead of multiplying by 1/2, you could also just divide by 2. And the area of this bad boy will be 133, and then we'll go put a label on it. Since area is in square units, we'll do that because there's 2 dimensions involved. There's like a length and there's a width, right? So we've got inches squared on that bad boy. So now as a trapezoid, here we have to recognize the type of quadrilateral, and you see we have 1 pair of parallel sides, 2 pair of parallel sides. That's our parallelogram in this case. So we do have a formula for him on the yellow card. The parallelogram is base times height. And the height, of course, always has to be something going perpendicular between the 2 bases. Right? So, bada boom. It doesn't really matter which one of these we use. We'll learn later this chapter, which you may have learned from middle school already, that those sides are the same length in a parallelogram. So we've got a 19 for a base and 8 for a height. So we'll sub in 8 times 19, and then we'll punch it in. 8 times 19. Boom, 152. And then the label will be centimeters squared, due to the fact that all area is in square units. And our next one, we have to recognize he's got 1 pair of consecutive sides the same, a second pair of consecutive sides the same. That's our weird boy. That's the kite right here. And here's the formula for him. So we haven't had to use the hierarchy yet. Area of a kite is going to be 1/2 times diagonal 1 times diagonal 2. That's what the D stands for in these formulas. So they tell us the distance from A to C is 22, and then they tell us that the distance from D to B is 9. Those are the 2 diagonals in this case. So it doesn't matter which one is which. One of them is 22, and one of them is 9. So we can do the same trick. We can do 22 times 9, hit equals, and then divide by 2 if we'd like, and get the area of that to be 99 square feet. So those were the 3 formulas that were on our yellow card. We didn't really need the hierarchy to help us out at all, but now we might, right? So when we recognize the type of shape of this guy, he's got at least 1 pair of parallel sides, and he's got these base angles equal. Well, that is an isosceles trapezoid. But the weird part is we don't have a formula for an isosceles trapezoid, but as plain Jane as it could be, like, don't you think that an isosceles trapezoid is also a trapezoid in that case? So anything that is above you, you will always be. So we can use the formula for that. We can just go, area is going to equal 1/2 times the height times the quantity of base 1 plus base 2, where the height is that perpendicular distance right here, And the bases of a trapezoid will always end up being the parallel sides. So we will sub in. Area is going to equal 1/2 times 26 times 37 plus 58. And I'll go figure out what 37 plus 58 is. And that's 95, so I'll lightly scratch that out and put a 95 right there. I just want to see that so I can see that you put the right numbers in the same, in the place that they're supposed to go. So 26 times 95, hit equals, and then divided by 2, 1235. And we'll go with inches squared. So we had to use the hierarchy to figure out the formula for the isosceles trapezoid, but kind of common sense. I mean, it's got the word trapezoid in it also. But when we get to a rectangle, even though middle school has taught you well, it's just like, hey, I don't have a formula on my yellow card for a rectangle. That's because a rectangle, you could use the isosceles trapezoids if you wanted to, which doesn't have one, which is really a trapezoid, or you could just go straight and go, yeah, that's like a parallelogram, right? It's going to be area equals base times height. That's what a lot of middle schools teach you. Some others teach you length times width. It's the same concept, so we'll use that, and that's going to be 3 times 11, which is 33 square yards. So using the hierarchy to realize that a rectangle's formula will be the same as a parallelogram's. And then finally, this guy, he's got 4 right angles and 4 equal sides. He's a square. Regardless of doing the hierarchy and realizing that it's still a rectangle, which is still a parallelogram, we're going to use the very specific formula for a square, which is area equals side squared, because that guy and that guy are the same lengths, right? So we're not going to call them a base and a height. We'll call them S for side squared, and area will equal 12 squared, which is 144 square inches. So just finding some basic area. Please write the formula down first and sub in. Let us know if you have any questions. Have a good one.